Students, welcome to Diamond Group of Institutions NEET and K-CET online classes. So today we are going to discuss about the thermodynamics. Okay, so one or two questions we may expect from this. Maximum one question based on the graph and one question based on the some formulas. Okay, so concentrate on the formulas, read the concept. Easy chapter, you can gain easily 8 marks. Okay, now so see the first question. A sample of gas expands from an initial pressure and volume of 10 Pascal and 1.0 meter cube, means 1 meter cube. Initial pressure given 10 Pascals, initial volume given 1 meter cube, to a final volume also given 2 meter cube. So volume changed from 1 meter cube to the 2 meter cube. During the expansion, the pressure and volume are related by the equation. They given the one equation, P equal to the A V square. Okay, I am writing here P equal to A V square. This is the relationship between the pressure and volume, where A value also given 10 Newton per meter power 8. Find the work done by the gas during the expansion. So during the expansion, what is the work done we have to find. So if they give this type of questions, okay na, very important this type of question, okay na. So last year they asked this type of question only. So P equal to AB square or any other term they will give. So actually we know the work done formula is W equal to the integral PdV, we know already. Okay, na? W equal to integral PdV. P is the pressure, here dV is nothing but the change in the volume. So now I am writing here PdV. So limits are initial volume to the final volume. So P value they given A V square. So P plus I am writing A V square into dV. So A is the constant, stand outside, and V square dV. V square ka integration. So x power n ka integration x power n plus 1 by n plus 1. So in that way we will get the V cube by 3. V cube by 3. Okay na. So that is integration. Now lower limit is 1, upper limit is 2. Okay, next 3 is the constant, stand out that side. So A by 3 equal to the, first substitute the upper limit, 2 cube means 8 minus 1 cube means 1. Okay, so 7A by 3 we will get, A value given 10, no? So substitute here, we will get the 70 by 3. So then work done equal to the 23 joules. Okay, na? Work done is the 23 joules. Next see the second question. Okay, so here this is the way. First we have to write down the work done formula, and next what is the relationship given, substitute here and do the integration, and substitute the do the integration from where to where, initial volume to the final value, substitute, and we will get the answer. This is the way to solve the question. This type of questions are very important. Okay, next to see the second question. The change in internal energy of a thermodynamical system which has absorbed 2 kilocalorie of heat. If it absorbs the heat, heat is positive. If it releases the heat is negative. We have to take sign convention. So it absorbs 2 kilocalories. 2 into kilo means 10 power 3. 1 calorie equal to the 4.2 joules. Then we will get the 8400 joules. Why I am converting this one means, see the next data, and work done 400 joule they given. Okay, so joule here kilocalories. So convert into the same unit system, because here options also joules only. Okay, so now heat absorbed, so positive 8400 joules. Work done by observing the heat, work done by the gas. If work done by the gas positive, work done on the gas, on the system. Work done by the system positive, work done on the system negative we have to take. Here work done by the system, so it is 400 joule. So from the thermodynamics first law, you know del Q equal to the heat given to the system utilized for the two ways. One is to increase the internal energy, and the remaining energy is for the to the external work. Okay, so now here del Q equal to del U plus W. This is the change, how much heat it is observing, okay, or releasing out. Del U is the internal energy. Okay, so W is the work done. Internal energy depending on the temperature. If temperature increases, internal energy increases. If temperature decreases, internal energy decreases. Now they are asking the internal energy. Internal energy means here they didn't mention about the temperature, but heat it is observing now. If it is heat observing, temperature increases. So internal energy also increases. So we will get the internal energy positive. Now internal energy equal to the W send this side, del Q minus W. So heat absorbed equal to the 8400 joules. So 8400 joules, work done is 400. So 8000 joules, but they given in terms of the kilojoules, we will get the 8k joules. 8k joule is the, this is the very simple problem, but don't make the mistakes. See, the sign convention is very important. Work, if it is observed, the system observe the heat positive, system reject the heat or release the heat negative. Temperature increases, internal energy positive, temperature decreases, internal energy negative. Work done by the system positive, work done on the system negative. Remember this sign convention. And next, see the next question. A monoatomic gas initially at 17 degrees centigrade. So initial temperature T1 equal to the 17 degrees centigrade. Okay. Suddenly compressed. Okay. Sudden process is nothing but the adiabatic process. Okay. In detail, it is not possible to teach now. Why? Because now this is the crash course. Already you know all these points, so once again we are revising. So suddenly compression means that is nothing but the adiabatic process. Okay. To 1/8 of its original volume. That means initial volume is V, then original volume is V by 8. 1/8 of suddenly compressed to 1/8 of its original volume. No? Original volume is V, then final volume is V by 8. So the temperature after compression is, what is the temperature after the compression? So in the adiabatic process, the temperature should be in the Kelvin scale, kelvins. Now they given the 17 degrees centigrade initial temperature, convert into the Kelvin. Okay, now add the 273. So 273 plus 17 equal to the 290 kelvins. Now temperature value after compression, what is the temperature we have to find? Okay, so in adiabatic process we know all the we know the three formulas are there. So I am using the first formula here. One formula from that three. T into V power gamma minus 1 equal to the constant. So according to this data, this formula is suitable. T into V power gamma minus 1 equal to the constant. Here we are comparing the two situations, before compression, after compression. So now T1 V1 gamma minus 1 equal to T2 V2 gamma minus 1. Okay, now we have to find the T2 value, then V2 stand this side, then T1 into T1 is as it is, V2 coming this side, V1 by V2, both have the same power. So V1 by V2 power gamma minus 1 into T1. V1 value is V, V2 value is V by 8. So V2 value V by 8 means 8 I am writing in the numerator. So gamma value, monoatomic gas. Remember gamma value, what is the value of the, for the gamma value for the monoatomic, diatomic, triatomic you have to remember. For monoatomic 5 by 3, diatomic 7 by 5 and triatomic 9 by 7. Already you know all these values, remember once again. Okay, so T1 value is 290, already we found that one. So now we cancel 8 power, 5 by 3 minus 1 is nothing but the 2 by 3. So 2 by 3, 8 power 2 by 3 into 290, 8 we can write it as the 2 power 3. So power 2 power 3 into 290, this 3 will be cancelled, 2 square we will get, 2 square value is 4 into 290, 4 into 290 equal to the 1160 Kelvin. So D option is the right answer. So this is the sudden compression adiabatic process. What are the formulas in the adiabatic process? We have to remember. Okay, one formula I am using from that. So like this you have to solve the problems. Okay, na? Next question, fourth one, 5.6 liter of helium gas at STP is adiabatically compressed to 0.7 liter. Initial temperature is T1, initial temperature T1. The work done in the process is, in the previous question we found the final temperature. In this question they are asking the work done. So here the process already they only mentioned adiabatic process. And next compressed, gas is compressed. Gas is compressed means work done on the system. If work done on the system, the work done will be negative. Work done by the system means positive. So we can cancel out two options easily, A option and D option wrong. B and C may any one option. Okay, now so first I am writing the given data. Initial volume they given 5.6 liter, final volume they given 0.7 liter, initial temperature they given T1 equal to T1 only, final temperature we don't know. Okay, they are asking the work done. So first I am writing the work done formula for the adiabatic process. Work done formula you have to remember, W equal to Nr del T by gamma minus 1. So it is equal to Nr T1 minus T2 by gamma minus 1. Remember here, if we write T1 minus T2, then here we will get the gamma minus 1. If we write T2 minus T1, we will get the 1 minus gamma. Remember that one. Don't get the confusion here. Gamma minus 1 na, 1 minus gamma na. Okay, see that one. This one more way also we will write from the ideal gas equation. PV equal to nRT na, so nR delta equal to gamma minus 1 na, so P1 V1 minus P2 V2 by gamma minus 1 also we can write, work done. If they give the pressure and volume, then we have to use that formula. Here they given the volume and temperatures. Okay, so see now here volumes and temperature they given, they are asking the work done. So now we got the work done formula. N value, number of moles, we don't know. R value, okay, options also are only given, okay. T1 value, okay, T1 we know. T2 value, we don't know. Gamma minus 1, helium is a monoatomic gas, so gamma value we know, 5/3. But here which values we don't know? N value, number of moles we don't know, T2 value we don't know. Okay, these two values we have to find first. So from the adiabatic process, in the adiabatic process, two volumes, so initial final volumes we know, initial temperature we know, final temperature we have to find. Already in the previous problem we found how to find the final temperature. So T into V power gamma minus 1 equal to the constant. By using this one we can write T1 V1 gamma minus 1 equal to T2 V2 gamma minus 1. I have to find the final temperature. So T2 equal to the V1 by V2 power gamma minus 1 into T1. V1 value is 5.6, V2 value is 0.7 power gamma minus 1. Gamma is the here gas is the helium gas, monoatomic gas, gamma value is 5/3. So 5/3 minus 1 into T1 value is T1 on the temperature. Now 0.71 to 0.78 to 5.6, so 8 times it will cancel. So 8 power, 5/3 minus 1 is nothing but the 2/3, already previously solved, 2/3 into T1. 8 power 2/3 is nothing but 4, 2 cube we can write, cube 3 will be cancelled, 2 square means 4, 4 into T1. So the final temperature is 4 into T1. So final temperature, this temperature we found. So that means we have to find the number of moles. Already in chemistry you know, 1 mole at STP occupies 22.4 liter volume. So if it is the helium at STP occupying the 5.6 liter means how many number of moles there? So the number of moles equal to the 5.6 liters by 22.4, then 1/4 moles. Okay na? So 1 mole at the occupies the 22.4 liters at the STP, 5.6 liter occupy the 1/4 moles. It has a 1/4 moles. Okay, now everything we found, substitute in the formula. W equal to the N value, okay, this form N value, N is a 1/4 R, 1/4, okay, 1/4 N value into R, T1 minus T2, T1 value T1 only, T2 value is minus 4 T1, and gamma minus 1, gamma value is 5/3, already I said monoatomic gas, 5/3 minus 1. Okay, simplify it, 1/4 R into T1 minus 4 T1 minus 3 T1, 5/3 minus 1 is the 2/3, 2 writing here, by 3 and 3 I am writing upside. So now 3, see now, minus 3 into 3, minus 9 R T1 by 4 into 2, 8, minus 9/8 R T1, minus 9/8 R T1. B option is the right answer. Okay, come to see the next question. So all the questions you have to remember, all the formulas you have to remember. In isothermal, adiabatic process, these two processes are very important. Okay, so work done formula and remaining relationship PV and T and TV, that relationships you have to remember. Okay, 2 mole of argon are mixed with the 1 mole of hydrogen, then Cp by Cv for the mixture is nearly they are asking, we have to find. So 2 moles of argon, so initially the argon first I am considering first one, so N1 equal to the 2 moles, and argon gas ka Cv value we have to find. So Cv ki general value V equal to the how much F by 2R, this is the general formula. Okay, so now for the monoatomic gas F is the 3, for diatomic gas 5, and triatomic gas 7, we will take that values already you know. So argon is the monoatomic gas, for monoatomic gas Cv equal to the 3/2R. Okay, so N1 Cv1. Okay, this is for the argon gas. Next, mixed with the 1 mole of hydrogen gas. So hydrogen gas I am second case, N2 equal to 1, then Cv2 equal to the general formula is F/2R. Hydrogen gas H2, diatomic gas. So diatomic gas ka degree of freedom is 5, so 5/2R. So now Cv2 equal to 5/2R. So now we got. So now we know already the formula for Cv mixture ka Cv mixture we have to find first. Okay, so then formula is N1 Cv1 plus N2 Cv2 by N1 plus N2. Okay, so Cv is nothing but already you know molar specific heat at a constant volume. Okay, now remember that. So for mixture we have to find the CV. So N1 CV1 plus N2 CV2 by N1 plus N2. N1 value is 2, CV1 value is 3 by 2 R, okay, plus N2 value is 1, CV2 value is 5 by 2 R. N1 plus N2, 2 plus 1, okay, na? N1 is a 2 moles, N2 is a 1 mole. So now 2 will be cancelled, we will get the 3R plus 5R by 2, all by 2 plus 1 means 3, okay. This do the simplification, 3 into 2 6, 6R plus 5R 11R, 11R by 11R by how much we will get, one more step I will write here. This is 11R by 2 all by 3 is there, we will get the 11R by 3 into 2 means 6 we will get 11R by 6. So already we know the formula Cp minus Mayer's rule, Cp minus Cv equal to the R, okay. So Cv value we got, or we know that means Cp equal to we will get from Cv plus R. So CV mixture we found, mixture ka Cv value we found, we have to find the mixture ka Cp value. So Cp value is nothing but Cv plus R, Cv plus R, mixture ka Cv value plus R. So mixture ka Cv value is 11R by 6, so 11R by 6 plus R. For simplification we will get 11 plus 6 is 17, 17R by 6. They are asking the Cp by Cv for the mixture is nearly, so Cp by Cv ka mixture, so Cp mixture by Cv mixture. Cp mixture कितना 17R by 6, 17R by 6. Cv mixture कितना 11R by 6, 11R by 6. 6 will be cancelled out, we will get the 17R by 11R. RR will be cancelled, we will get the 17 by 11. 17 by 11 means 1.5 something we will get. So nearly it is equal to the 1.5. So option D is the right answer, 1.5. Okay, like this you have to solve the problem, easy way. First find the Cv mix. Why? Because for any gas we can find the Cv value very easily, 5 by 2 R, 5 is the degree of freedom. Okay, remember, proceed, follow this one, you will get it very easily. Okay, next see the question. This is the very silly question, small question only, but maximum student will make the mistake. Okay, so see in the following indicate diagram, the net amount of work done will be. What is the net amount of work done? Just positive or negative we have to see. So remember, if they give the PV graph, PV, so work done equal to the, already we know, so dW equal to the P into dV. That means the area enclosed by the graph will give the work done. So here this is the closed curve now. So area of this enclosed is give the work done. Okay, so here per PV only, you have to remember PV graph, area enclosed by the curve will give the work done. Okay, if VT graph, PT graph is there, different method. Okay, na? So next here we have to find the work done by this one and work done by this one. And the next one more thing you have to remember, if the cycle, here see the curve, this is in the clockwise and this one is in the anti-clockwise. So if it is in the clockwise, then work done equal to the positive, and if it is in the anti-clockwise, then work done will be the negative. So for first cycle work done is the positive, for the second circle work done is the negative. Okay, for first cycle it is moving in the clockwise direction. Okay, in the second cycle is anti-clockwise direction. So clockwise direction work done is positive, anti-clockwise direction work done is negative. So the area enclosed by the second circle is more than the first circle. You see the diagram, first one is the small, second one is the big. So that means area enclosed by the second is the more, area enclosed by the first is the less. That means the negative work is more, positive work is less here. So the network will become, what will become? Negative only. Negative is more, na? So then we will get the network is the negative only. So network equal to the net amount of work done will be negative. Like this you have to see. Easy question. Okay, na? So area enclosed by the PV graph is will give the work done. Only per PV graph I am saying you. Okay, so this circle is the small and this circle is the big. So here work done is a clockwise direction is there, so positive. Here negative, anti-clockwise direction is there, negative. So this area is more, so resultant also will get the same sign of this one only, so negative. That big circle has the negative, so negative sign only we will get, network is the negative. So like this you have to do the problems. See the next problem, 7th question. The 7th and 8th both are very important questions. So every time they are asking one question on the graph. So here I am explaining two questions on the graph. First question, see now, here I am taking the graph, PV graph, here I am taking the VT graph. Okay, na? PV graph we can do it very easily, but VT graph, VT or PT, whatever it is, to the process. Okay, na? I will tell you, just listen. Now see the 7th question. A thermodynamic process is shown in the figure. The pressure and volume corresponding to some points in the figure are. Okay, pressure and volumes are given. Pressure at the A point ka pressure given, volume at the A also the given, and pressure at the B ka pressure given. A is at the pressure 3 into 10 power 4 Pascal, means D is also at the same pressure. Okay, na? Same pressure. B is at some pressure 8 into 10 power 4 Pascals, means C is also at the same pressure. Okay, next volume, A volume they given 2 into 10 power minus 3. A is at the volume 2 into 10 power minus 3, means B also at the same volume. And D ka volume given. D volume is 5 into 10 power minus 3, means C. That means VA value they given, VA equal to the VB, volumes are same. VD they given, VD equal to the VC. So volume of A, volume of B, volume of D equal to volume of C. And pressure at A equal to the pressure at D, and pressure at B equal to the pressure at C. Remember these values. Okay, now they given some values. See now in the process AB. So this is the AB process. In this process, 600 joule of heat is added given to the system. Next, and in the process BC, B to C, 200 joule of heat is added to the system. 200 joule of heat is added. Okay, so the change in the internal energy of the system is process AC would be. In this AC, we have to find the internal energy. See the curve carefully. The curve is from one. We have the 3 paths here. This is not a closed cycle. If the cycle is closed, then internal energy equal to 0. Internal energy depending on the initial and final points only, not on the path. Okay, it is the path independent, not dependent. So now A, B, C, one path. A, D, C, second path. A to C, 3 paths are there. For 3 paths, initial and final points are same. That means in the 3 paths, the internal energy is same. Okay, if you find the internal energy through one path, that is equal to these 3 paths. Okay, na? So some data given about the A to B, B to C. This curve they given some data. So by using that data, we have to find the internal energy for this curve. The internal energy of this curve is nothing equal to this curve internal energy, and for this internal energy also. Okay, na? So 3 paths have the same initial and final points. So internal energy is same for the 3 paths. Okay, if you find the internal energy for the one path, that is enough. Okay, na? So now see, I am considering the A to B, B to C path. A to B, B to C path. So now A to B, B to C path, they given A to B 600 joule heat added, and B to C 200 joule of heat is added. Total heat how much added? Either 600 heat added, either 200 heat added. Total heat added is 800 joule added. So heat added to the path A to B, B to C is nothing but the 800 joule. For this path, heat added is 800 joule. And next see the curve. So 800 joule. To find the internal energy, from the first law of thermodynamic, we know the formula del Q equal to the del U plus W now. Del Q, how much heat added or rejected. Okay, na? So here heat is added, that we found already, 800 joule. So to find the internal energy, we need the work done. So work done we have to find. So see now, we are considering the path A to B, B to C path. A to B, see now, this is the PV graph. A to B, volume is constant. If volume is constant, work done equal to the 0. There is no expansion, there is no compression. So work done equal to the 0. So A to B work done equal to the 0. A to B work done equal to 0. Next to B to C we have to find. B to C work done. For PV graph, I said already, the area under the curve will give the work done. So now area under this BC curve will give the work done. Okay, now see, area under the BC curve, work done equal to the, so either the pressure and from here to here volume difference. B, C both are have the same pressure. So pressure into change in the volume. Already we know the work done formula, work done equal to P into dV we will write now. So pressure into change in the volume. So B, C both are at the same pressure. The pressure value is nothing but the PB value kitna given, how much, 8 into 10 power 4 Pascals. So PB value given 8 into 10 power 4 Pascals. Change in the volume. VP, change in the volume means final volume minus initial volume. VC minus VB. Actually we have the VC minus VB. VC and VD both are same. Already I said VC, VD. So VB, VA both are same. Already I said VB, VA. So VC minus VB is nothing but VD minus VA. Okay. VC minus VB is nothing but VD minus VA. Why? Because they given VD and VA values. So VD minus VA. VD value already given, VA value already given. Substitute and simplify. We will get the 240 joules. So work done from A to B, B to C equal to 240 joules. A to B is the 0, B to C is the 240 joules. Total work done equal to 0 plus 240 joules. That means from A to B, B to C path, heat supplied is 800 joules and the work done is 240 joules. Then what is the internal energy we have to find from the A to B, B to C path? Okay, now from the first law of thermodynamics, del Q equal del U plus W. So internal energy equal to the heat added minus work done. Heat added is 800 joule minus work done is the 240. So 560 joule internal energy. So it is added na temperature increases, internal energy also increase. Now internal energy is 560 joules. So 560 joule is the, that means here this is the internal energy for the A to B, B to C path, for this path. Okay, so already I said these three paths have the same initial and final points. So if you find the internal energy for any path, that is equal to all the paths. So in this path the internal energy equal to 560 joule, means in this path also internal energy 560 joule only, in this path also internal energy is 560 joule only. Why? Because internal energy is the path independent, it depends on initial and final positions only. So they are asking the internal energy in the AC process. So in this process also internal energy is same, that is the 560 joule. A is the right option. Now come to see the 8th question. This is the very important question. An ideal monoatomic gas, remember. So undergoes a cyclic process ABCA, cyclic process this one. Cyclic process means internal energy equal to 0. Okay, total if you consider one curve individually, then different individually we have to find. But if we consider total curve, internal energy equal to the 0. Okay, so the ratio of heat absorbed during the AB to the work done on the gas during the process BC. Okay, first see the AB process. So this is the AB, BC, CA, cyclic process. Okay, now A to B, how much heat absorbed, that we have to find first. Okay, A to B, how much heat is absorbed. So to find the heat absorbed, already we know del Q equal to the del U plus W, this formula. To find the heat absorbed, we have to find the internal energy and work done. This is not a PV graph to find the area under the curve. This is the VT graph. Okay, for PT graph also you have to follow the same procedure. Okay, so now heat added, to find this one we have to find the internal energy and work done. So which process we are considering? A to B. So if you see this curve is passing through the origin. Okay, now curve is passing through the origin and increasing linearly. So and the graph between the V and T passing through the origin and increasing linearly, that is nothing but, that process is nothing but the isobaric process. A to B is the isobaric process. That graph is indicating that V is directly proportional to T. Okay, now this graph is indicating V is directly proportional to T. V is directly proportional to means pressure is a constant. So isobaric process, that one. So for isobaric process, work done formula nR del T. Okay, na? So nR del T. N, suppose I am considering nothing they mention, n equal to 1 I am taking. So n equal to 1 R into del T. So A to B, what is the temperature difference? So either temperature is T0, either temperature is 2T0. So temperature difference is 2T0 minus T0. So they will get the R T0. Okay. So in one more case I am writing, suppose in the options, in other questions, pressure volume they given, how to do that means I am telling you. So from the ideal gas equation, nRT is then a PV equal to nRT. N equal to, I consider one more. Initially P0 V0 equal to N is 1 R T0. That means R T0 plus we can write the P0 V0 also. Okay, remember that one. So work done completed. Okay, so to find the heat added, work done, internal energy we have to find, work done completed. Internal energy we have to find for A to B process. A to B process, the internal energy equal to the formula, remember, F by 2 nR del T. Okay, na? F by 2 nR del T. F is the degree of freedom. What is the gas here? Monoatomic gas. For monoatomic gas, degree of freedom is 3. So 3 by 2. N is, I consider 1. So 1 into R means R. del theta. So from A to B del theta already I said this is at the T naught, this is at the 2 T naught. So 2 T naught minus T naught. Then how much we are getting? 3R by 2 into 2 T naught minus T naught is the T naught. 3R T naught by 2. R T naught I said already P naught V naught. So 3 P V naught by P naught V naught by 2. Okay na? Without writing this P naught V naught also we will get in some any other question come. For this question no need to write this one. If any other question is there, that purpose I am explaining. Okay na? So now work done in this process completed and internal energy also completed. Now find the heat absorbed. Okay, heat added. So heat added equal to the Q equal to the work done plus internal energy. Work done equal to how much? P naught V naught, P naught V naught. Internal energy equal to how much? 3 P naught V naught by 2, 3. So total LCM we will get the 5 P naught V naught by 2. Okay. And the next two, they are asking the work done on the gas during the BC. Okay, now see the BC curve. Okay, first we have to identify the what is that process. In the AB also we identify that only. That is the isobaric process. For isobaric process formulas I used. And the second case they are asking the BC. For BC, what is this one? Either temperature is constant. If temperature is constant, that is nothing but the isothermal process. So now B2C is nothing but the isothermal process. For isothermal process we know the work done formula. So that is nothing but nRT ln V1 by V2, V final by V initial. Okay. If I don't use if I use the log base 10, then I have to multiply with the 2.303. So now ln only, options ln only there in. Okay, now nR temperature. This curve at what temperature? 2T naught. So at the place of temperature I am writing the 2T naught and ln V1 by V2, V final by V initial. So B to C means C is at the final, B is at the initial. Initial volume is a V naught, final volume is a 2 V naught. So final volume by initial volume. Final is a V naught, initial is a 2 V naught. So NR into 2 T naught means 2 NR T naught log of ln V naught by 2 V naught. So then how much we will get? 1 by 2 we will get 2 power minus 1 we will get minus we will get here. So I am taking the mod ratio we have to find. So mod minus we should not take, plus only I am taking. So now already n equal to 1 we know. I consider n equal to 1 and RT naught value also we know P naught V naught. So at the place here I am writing 2 into n plus my 1 RT naught plus my P naught V naught ln 2 is there ln 2. Okay, this is the work done in the BC process. Suppose if they ask AC also, for AC is nothing but volume is a constant. If the volume is a constant, that is nothing but the isochoric process. Volume is constant means work done equal to 0. In that way you have to do. So now the question they are asking the ratio of heat absorbed during the AB. Heat absorbed during the AB to the work done on the gas during the BC. This they are asking. QAB equal to how much we got? 5 P naught V naught by 2. 5 P naught V naught by 2. W is work done in the BC process. How much we got? 2 P naught V naught ln 2. 2 P V naught V naught ln 2. So rewriting 5 V naught V naught by 2 into this is I am writing 1 by 2 P naught V naught. 2 P V naught P this will be cancelled. 5 by 2 into 2 4 ln 2. Okay now. So the option is 5 by 4 ln 2. C is the right option. Like this you have to solve this problem. This is the very important problem. Okay. Next problem based on the Carnot engine and refrigerator, and one more is the temperature entropy. So these are so important problems. Carnot engine whose efficiency is 40% takes its heat from a source maintained at a temperature of 500 Kelvin. Okay, so temperature, it is taking the temperature from the source ka temperature is 500 Kelvin. It is desired to have an engine of efficiency 60%. So to increase the efficiency, then the intake temperature for the same exhaust sink is same here. That means from the source it will absorb the heat and it will reject the heat to the sink. So two cases given. First case mein efficiency is 40%, second case mein efficiency is 60%. First case mein it is absorbing the heat, it is taking the heat at 500 Kelvin temperature source. And second case mein to increase the efficiency, what is the intake temperature? In the both the cases heat rejected is same. Okay, both the cases heat rejected is same. So now they are asking the intake temperature of the same exhaust, means same sink temperature must be. Okay, intake temperature we have to find in the second case. So here sink is same, sink ka temperature is same, that means same amount of the heat rejecting. Okay, but intake temperature is different here. Why? Because efficiency different. So first case mein efficiency is 40%, so 40 by 100. First case mein it is source is at the temperature 500 Kelvin, and exhaust sink cooker temperature I am assuming as a T. We know the efficiency formula for the heat engine, neta equal to the 1 minus sink temperature by source temperature. Remember, okay na? Sink temperature by source temperature. So neta 1 equal to 40 by 100 equal to 1 minus T2 is the sink temperature T, T1 is the source temperature 500, T2 by T by 500. So simplify it, okay na? So T by 500 send this side, 40 by 100 send this side, then 1 minus 40 by 100 is the 60 by 100. So simplify it, we will get the T equal to 300 Kelvin. T is nothing but source का temperature, sorry, sink का temperature. दोनों two cases में sink का temperature is same. That means either sink का temperature, in this case sink का temperature is 300 Kelvin we got. Here also sink का temperature, T2 dash is nothing but a sink का temperature. Here also 300 Kelvin only. We have to take the intake temperature, source temperature, how much to increase the efficiency to 60%. Okay, so neta 2 equal to 60%, 60 by 100. Intake temperature we have to find T1 dash. And source sink ka temperature we found already here. Both the cases sink ka temperature is same. Same formula, neta equal to 1 minus sink temperature by source temperature. Neta in the second case 60 by 100, 60 by 100, 1 minus sink temperature we found already 300 by T1 dash. Intake temperature we have to find in the second case. So now simplify it, 300 by T1 dash send that side, 60 by 100 send this side, and simplify, we will get the T1 dash value is 750 Kelvin. If both the cases sink ka temperature same, and if intake temperature is 500 Kelvin, efficiency is 40%. If intake temperature is 750 Kelvin, then efficiency increases and it is the 60%. Like this we have to solve the problem. Two cases here we have. And the next come to see the next problem on the refrigerator. The difference between the refrigerator and the Carnot engine is intake temperature is more for the Carnot engine, reject temperature is less. Okay, so reject is less, and in the refrigerator intake is less and reject is more. Intake is less, reject is more. That's why if you open the refrigerator, it will take less and it will reject more. So room will become hot, not cool. Okay, now so a refrigerator is to maintain a label kept inside at 900 degrees. So inside temperature is 900 degrees. So intake 900 degrees centigrade I am taking. This is the intake. Intake is the less, 900 degrees centigrade. And coefficient of performance of the refrigerator, if room temperature is 36 degrees and outside temperature equal to the 36 degrees centigrade. So 273 plus. Actually in the refrigerator or Carnot engine, the temperature should be absolute temperature in terms of the kelvins only. If they given in degree centigrade, convert into the kelvins. So 36 degrees centigrade convert into the kelvins. So add the 273, we will get the 309, and 9 degrees centigrade also convert into the kelvins, we will get the 282 kelvins. Intake is the 9 degrees centigrade. Reject is the 36 degree centigrade. So now efficiency formula, performance, coefficient of performance formula already we know, alpha equal to T2 by T1 minus T2. Okay, here alpha, or in some books they will give the beta also, whatever it is notation. Okay, T2 is the intake temperature by rejected minus intake, remember in this way. So T2 is the intake, 282 Kelvin, 282 by T1 is the 309 minus 282, simplify, we will get the 10.4. So remember the formula of the refrigerator and remember the formula of the Carnot engine, both are important. See the next question, the entropy, the temperature entropy diagram of a reversible engine cycle is given in the figure. Its efficiency is the efficiency we have to find. First I am going to write the formula, entropy equal to the heat absorbed or rejected per absolute temperature. From this del Q equal to the del S into T, okay na, del S into T either. So heat absorbed or rejected, how to find means the area under this curve will give the heat absorbed or heat rejected, that we have to find. Next one more thing you have to remember, if entropy increases, heat added to the system. If entropy decreases, heat rejected by the system. Remember the 2 points. And the next efficiency we have to find. Efficiency formula already we know W by Q1. W is the work done. Q1 is the heat added to the system. So W we can write it as a Q1 minus Q2 by Q1. After simplification we will get 1 minus Q2 by Q1. That means Q2 is the heat rejected by the system. Q1 is the heat added to the system. So we have to find the where heat is rejected, where heat is absorbed heat we have to find. How to find the heat? The area under the graph will give the heat. Okay na? So we have to find step by step. First I am considering the first curve this one, second curve this one, third this one. So here the curve is showing this is the process from here to it is moving. Here the entropy is S0 and here the entropy is the 2S0. So entropy increased. If entropy increases, heat added to the system, so heat is the positive. So first curve Q1 equal to the area under this curve. Okay, area under this curve. So area under this curve I am splitting into the 2 parts. So here this is the triangle and this one is the rectangle. Okay, so first I am considering the rectangle. Area of this rectangle, length here to here length kitna 2S0 minus S0. S0, this is the S0 and this breadth kitna T0. So length is the S0, breadth is the T0. So rectangle ka area length into breadth. Length into breadth, T0 S0. And next this triangle ka area half into base. This is how much? 2S0 minus S0. S0, so half into base S0 into height this much. Here 2T0, either T0. Okay na. Here to here T0, here to here 2T0. This is nothing but the 2T0 minus T0 to T0 only. So half base into height. Okay, from this we will get the 3S0 T0 2. So the area under this curve is giving Q1 equal to 3S0 T0 by 2. Here entropy is increasing from here to here. So heat is added to the system. Heat is the positive. Q1 is the heat is added. Next second curve see now. From second is going from here to here. In this process we have here to here it is going. So now area under this one we have to find. So area under this one is, so this is nothing but the breadth, this is the shape is nothing but the rectangular shape. So this is nothing but the width is nothing but the T0, length. So from here to here 2S0, from here to here S0. This is nothing but the 2S0 minus S0 is the S0. Okay, but final is the S0, initial is the 2S0. From here to here it is going now. So S0 minus 2S0 equal to minus S0. So here we are getting minus T0 S0 means, see the process is moving from here to here. Entropy is increasing or decreasing or decreasing. If entropy decreases, heat rejected by the system. This minus is indicating heat is rejected by the system. Okay. Next third one see now. Here entropy is S0 only. Entropy is not changing. Entropy is constant. If entropy is not constant, energy not added and energy not rejected. So the heat energy not added, heat energy not rejected. So Q3 equal to the 0. So heat equal to the 0. Now Q1 is the heat added to the system. Q2 is the heat rejected by the system. And for the third curve, heat equal to the 0. Now efficiency we have to find. Efficiency equal to 1 minus Q2 by Q1. So 1 minus Q2 value. Q2 is nothing but the heat rejected. Heat rejected value is T0 S0. Don't take the minus. This minus only indicating that rejected. So T0 S0 by Q1 value. Q1 is nothing but the heat added. Heat added is how much? 3S0 T0 by 2. 3S0 T0 by 2. So okay, 1 minus S0 T0 will be cancelled. This 2 will go upside. So 2 by 3 it will become 1 by 3. So now the answer efficiency is the 1 by 3. In this way you have to solve all the problems. Thank you. Practice seriously.